So one of the things that this 15.4 does is allows two topologies. It not only allows a star like we saw in the Bluetooth, it also allows mesh. Mesh means, you could be connected to multiple nodes. Now there are two types of devices. So this is star and this is peer-to-peer mesh. There are some devices that have more power and therefore can do more functions. So they are called full function devices. And some which have less power, they are reduced function devices. And if one of the full function devices becomes a coordinator. So in a sense, there are three functions. One is just be a node somewhere in the network. Second is be a coordinator. And third is be a leaf. Okay. The reduced functions are only the leaves. They can only be the leaf. They cannot send somebody else's packet somewhere else. Whereas these full function devices can forward packets. Alright, and coordinator can do more than forwarding the packets. It can hold your packets, it can make you sleep, it can go to, a lot of other things that we'll see. Yeah.
Is there any reason you titled it peer-to-peer on the bullet point, but mesh on the diagram?
Yeah. Right. So, it's the same thing. Two names for the same thing. Peer-to-peer mesh. Alright, so now you understand the difference between a star and the mesh, or the star and peer-to-peer, and you understand the difference between RFD and FFD. Right? And you understand the difference between FFD and coordinator. Okay? So, alright, so what does coordinator do? Any FFD can become a coordinator. Alright? So, when a network is formed, everybody says, okay, I want to become a coordinator, I want to become a coordinator, and then we elect one coordinator. Just like in the Ethernet, everybody says we want to become a root, and then we elect a root. Right? Yeah.
But there I think that we use based on the address.
Right.
But
so there is, hold on. So there is, in the Ethernet case, there is a procedure by which we elect the root. And so there are several things such as priority, address, and so on and so forth. And whoever has the highest priority and the lowest address wins, right? Exactly the same thing can be done here. And that's a very standard practice, is that you first take the priority. Why priority? Because the owner sets the priority. So the owner can say, my TV has to be the coordinator. Okay? So that regardless of what its address is, if it's highest priority, then it gets the job. Okay? So highest priority, lowest address. If you have more than one TV, then you have to decide whether which TV becomes the coordinator, right? So that's the idea here. FFD can become a coordinator, can also route messages to other nodes. RFDs cannot become a coordinator and can only be a leaf. FFD that starts a pan becomes the coordinator. Okay? So that's another thing is that, you could just say that, okay, I am the coordinator. If you want to join, just come on and join. And if you join, then, he is coordinator by the default. That's easy. In the star topology, all communication is to and from the coordinator. So in this topology, you can see everybody is a leaf, and the leaf cannot talk to the leaf. They talk to the coordinator. In P2P topologies, FFDs can communicate directly also. So in the P2P, the communication does not have to go through the coordinator, it can just go straight. That's why it's called P2P. Each piconet has a PAN ID and is called a cluster. So now this whole thing is called a piconet. It has a personal area network, PAN ID, identifier, and network ID, and it is called a cluster. So you could have many clusters. Nodes join a cluster by sending association request to the coordinator, and the coordinator assigns a 16-bit sort address to the device, and they use 64 bits. So basically what happens is, in your home, you have, let's say in an apartment, in a big apartment, let's start with shopping mall. Okay, in a shopping mall there are many shops, each of them are using Zigbee, let's say. Right? So you don't want your Zigbees to come and be controlled by the next door neighbor, right? So you will have your own cluster, your own coordinator, They will have their own cluster, their own coordinator, and so there is a quite complicated procedure by which you make sure that they know who is their master. So it's like when you get a remote controller, you get anything, you have to associate them. And once they're associated, they know what they control, who controls whom and all that, right? So basically, after that procedure is done, then every node knows who is their coordinator and what network they will join when their power is turned on. Okay, questions?
Can the network have more than one coordinator?
Can the network have more than one coordinator? Okay, so basically, that is something that one can do, although it would be more like a standby coordinator rather than a full coordinator, like in the sense that I could be a coordinator and if I die, somebody else will somehow, have all the information as to who the members are and things like that, and then continue the network, but just one is enough. Okay, let's see. So right now, let's just assume that there is only one coordinator in the whole network and there is only one PAN, and so I will have to figure it out later on and with you as to what you read, right? So let's just assume there is only one coordinator. Now, once you join the network, then we use only 16-bit address, just like I said before. Okay, so you get your nickname, and so whoever joins first gets number 1, number 2, number 3, and so on and so forth. And then generally the network doesn't really reach 16 bits, but this is designed for 16 bits. Now, the whole network, maybe this is what you read, the whole network could be many clusters, right? So here is a cluster, there is another cluster, there is another cluster. And the devices, the information can go from cluster to cluster to cluster. It can go from here to there. Right? So each cluster is a PAN, and each PAN has a coordinator. Right? But many PANs can be connected together and the packets can go. Right? And we'll talk a little bit more about the connection in a minute. So, and you can see FFDs and RFDs. And one thing you should notice is that if they are connected to two devices, they cannot be RFD. RFD can connect to only one device, so they are always the leaf. Anything that can connect to two devices is a full function device. And the whole thing is a tree. So if you were to hang off, you see, it's no longer a mesh as we shown in the beginning. So there is no loops anywhere inside or outside. Coordinator asks another FFD to become a coordinator for a subset of the nodes and the trees. So what can happen is, now this is what I think you are probably talking about, is that if this is the coordinator and all these nodes join that tree, join that PAN, then this could say, well, I think these guys are too far from me, and it can ask this FFD to become a coordinator. So now there are two IDs. Okay, yeah.
In practice, is there like a common radius for a personal area network, or could these things go?
Yeah, so in practice, the question is, in practice is there a common radius? So the radius is not specified by the standard, but in practice what happens, you go to the next room, there is no network. So power level puts the limit as to how far your network will reach. And then you will have to either put a bridge or something to, connect devices in that room. Okay? And that's what exactly here is happening, is that you are here and then you want to connect these here, then I think more than that device automatically saying anything, the person who owns all this will set up things so that they have different PANs and they're connected. Okay, so why you're saying, why don't we just connect this to that? Just like we do in Wi-Fi. Yeah, reason we cannot do that is because we don't know where it is sitting. So this could be on this corner of this room, and that could be another corner of that room, and there is no wire. I mean, these things are not connected to a wire, right? In Wi-Fi, the idea was that the base stations are connected by this backbone, right? And we do that by design. I mean, all of these, You see this, I think this is a base station probably, I don't know. And so that is connected by a wire in the back, right? And so they can be connected. But here, this cannot reach, there is no way this can reach there. Because of the distance, right? So the only way whoever is near there connects to whoever is near there on the other side. So these two happen to be on the edge, and they get connected, right? Okay, your question?
No, I said that we cannot even have any loops, so we cannot connect the time coordinators together.
We cannot have
Loops. So
loops.
we cannot, yeah.
Oh yeah, he's saying that it will become a triangle if you connect it like that. Okay, that's a valid one, but I think the main reason is the distance.
Yes, the main reason is
Okay, good. So far, so the main idea of giving this lecture was so that from now on, when you read any of this, you will see a lot of FFD, RFD, LFFD, RFD, mesh. These are things that people discuss, and you have to know that.